Hello, I'm Siva Sivaram. I'm the President of Technology and Strategy at Western Digital. I want to talk to you about the future of Flash. We at Western Digital have been taking this media, Flash, that has transformed industries, that has enabled new markets, revolutionized data infrastructure. What are we doing with our leadership position in this storage marketplace? The medium called Flash, that we have been instrumental in innovating for the better past of 2 decades, has been a building block of this new data economy. Think of the data storage as an infrastructure. People talk about the logic, the Moore's law scaling of the processor. They talk about the memory, that is the DRAM that is needed to work with the processor. But when you switch on your computer in the morning, when you log on, or when you go download something from the cloud, your data sits on the right side of the picture that you have in front of me in storage. Across the processor, across that storage interface, whether that interface is a consumer interface such as USB or an advanced enterprise interface like an NVMe PCIe or a SAS or a SATA or a UFS or a eMMC, across that interface on the right side, whether it is a consumer product, a embedded mobile NAND product or an SSD or a big data lake with petabytes of storage, that is what Western Digital provides. Western Digital provides a complete suite of storage products. Solid state, rotating media, big arrays, that's the bread and butter of this wide spectrum of products that Western Digital provides. The growth in this set of storage media that is needed has been exploding over time. You can see over the last decade, the growth of HDD and Flash. As mature as HDD is, as large that install base is, it's still growing at 17% CAGR. On top of it, Flash is growing at close to 40% CAGR. That impressive growth in data and the diversity in applications, that's what makes this space and these media very, very interesting. You can see we define when a business switches over to mass adoption of that media by saying about 10% of the install base, if it switches to the new media, we call it it's mass adopted. Last decade, in the early aughts, all of imaging switched over to Flash. In the early part of last decade, all mobile media, whether it is your audio devices, your cell phones, all those became Flash dominated. And then came PCs, both in notebook and desktop. About now, gaming is switching over. But the enterprise, you can see, even as much as in 2023, only about 10% of install base of enterprise is still going to be in Flash. That allows us that big opportunity, or to say it differently, Flash and hard drive in enterprise will exist together. Whereas they were replacement technologies in other industries, in the enterprise, for the foreseeable future, they are complementary technologies. This is where the power of our presence in Flash, HDD, and even other media makes it so much more synergistic. These synergies are in the customers who use the same products, whether it is in the standards that apply from both of them, even in new materials and technologies that we are now developing together with Flash and HDD. That synergy is a huge power that benefits our customers. So you can see this big growth over time into 15 zettabytes of storage that is needed by 2025 that needs to be supplied by a large extent by our HDD and a big impactful presence with Flash. how do we respond to this large need in flash demand? Let's look at this industry as a whole, what has been going on in the industry. The industry has been going at a steady 35, 36, 37% clip in bit growth rate over the last decade. That's no sign of slowing down. Look at the revenue. Revenue is growing at almost 9% CAGR over the last decade. Except for that little 3D NAND dominated bulge in the middle, that curve is essentially a continuous 9% curve. That is a substantive growth for an industry that has been around for 20 years to continue to grow at a 9% CAGR, 35 to 40% bit growth. That is what makes this a challenging, innovative, and a fun industry. But one that is dominated by this one word, capital. For us to go create these bits, we need capital, and the only reason the bits grow, and you can talk about, everybody talk about bit cost and this and that, in the end it is all about capital efficiency. You can see now, to create that next exabyte, we have reduced the cost of capital needed, the whole capital investment needed to create that next exabyte by over 80% in the last 10 years. That's driven entirely by technology. This technology and scaling, you can see the story developing. Technology and scaling reduce the cost to produce that next exabyte. When that cost drops, you end up with new markets. When that new markets grow, there's opportunity for revenue growth. That revenue growth allows the investment back to create the technology that causes that capital efficiency. You can see this virtuous cycle working out over the decades with flash. But that scale needs to be scaled up. This is where the power of the larger scale is important. What you see in front of us is the Levi's Stadium, which is a couple of miles from where we are in Milpitas. It's a big stadium that can hold almost 85,000 people. Along with the parking lots, that is a big, massive structure. Imagine taking 9 of them and putting them next to each other. That is the size of the fab complex where this flash is produced in partnership with Kioxia in Japan, in Yokkaichi. Our partner Kioxia and us together have this mega fab that produces almost 40% of the world's flash between this and the sister complex at Kitakami. That's the size and the scale that makes us different. 40% of the world's flash, along with the R&D investment that is shared between the two of us, produces us the most efficient capital investment needed to produce those flash. Technology scales, capital is scaled, you produce what is needed for this industry to grow. The other major innovation that Western Digital in manufacturing these devices that has done is in this idea of an integrated wafer in, product out assembly lines. Pigs in, sausage out. You get the wafers in and they come out fully done, ready to ship. Wafers in, box out. Look at the scale of this. 4.7 million die equivalents per day. In the time that you go to sleep and get up in the morning, we have already made 150,000 SSDs in those factories. This innovation allows us the speed, new product introduction, time to market, automation-induced productivity improvement. This is a unique facility. So we take it all the way, not just in the wafer fab scale, but in the back-end scale. So let's stop there and now look at the technology. We produce these wafers. What's so special about them? Why are they good? What's the figure of merit? What we say is this: In memory technology, in NAND memory technology, everything starts with the cell. That NAND flash charge trap cell that's shown in the middle, if it is good, everything can be better. If that's bad, nothing works. We have the best cell in the industry. Marry that with a very scalable process architecture, put a powerful CMOS engine that drives those bits and arrays, assemble them in the most efficient fashion, and test them at the most judicious parts, and you get a set of technologies that's the lowest in cost, lowest in power, best performance, reliability that you can predict, and conversion of that technology into product in the most timely fashion. Good inputs lead to good outputs. Proper ingredients in the quality of the cell, in the process architecture, in the CMOS, and in converting into product produces the cost, the power, the performance, the reliability, and the time to market of this product. And I'm going to show each of these how we differentiate ourselves in the marketplace. We need to satisfy our customers. We need to satisfy the new workloads and the new use cases that are coming up. We need to lead the industry to where we want it to go. We need to do better than the competition and provide satisfactory product to the customers. That's what we are trying to do here. So let me illustrate that with a product. I have in my hand a Western Digital enterprise class 16 terabyte SSD. You can see inside the 32 BGAs that are in the front and the back of that card. Each of these BGAs have 8 NAND die within them. Surely we can do 16 die, and surely from the 512 gigabit die that is inside, we could put a terabit die inside, and soon we can have a 64 terabyte enterprise SSD possible. That, to be able to get 16 terabyte, 32 terabyte, 64 terabyte in that smaller form factor, that illustrates the power of Western Digital's vertical integration. How does that work? First thing you need to do is, yes, along with the die, come with the assembly technology. Being able to take those die and do these surface mounts of 8, 16 die, one above the other, and be able to interconnect it. Assembly technology vertical integration is a key part in our ability to convert a die into a product. Let's go into the core wafer silicon processing technology itself. We talked about capital efficiency, how we have to have the capital to be most productive. The best way to do it is the traditional Moore's law, except as we know we have taken Moore's law into a new dimension, into both the Z direction and into logical scaling. So when we did the 48 layers, BiCS2, where I had 1 bit, just by going to 96 layer, I got to 2 times that, 2 times the number of bits. But more efficiently, because I laterally scaled on each layer itself, I got that to 2.6x. Now if I get from 3 bits per cell to 4 bits per cell, that 1 bit on 48 layer becomes 3.5 bits per cell. That's the power of scaling in those 2 generations going from 48 to 64 to 96 layer. Let's talk about this a little bit more. Lateral scaling has often been overwhelmed in people talking about how many layers people add to. The most effective way to get scaling inside the wafer is by shrinking laterally and then multiplying it by the Z direction, the number of layers. So the first thing we did, of course, is to reduce the size of those memory holes, make them as dense as possible. That's very, very difficult to do. The deeper you go, the deeper holes you have to drill, you cannot get them so close by. So what do? We introduced the world's first 2-tier You etch halfway, get another set, move as you build the skyscraper, move the cranes to the next floor, and then build again. And then we went consciously after reducing overheads. Every possible way, customer pays for a bit, not for the overhead. So reduce as much of it. And then in the last step, see if I can take the driver engines and put that parking lot under the skyscraper. That's how we have consistently, every generation, reduced the amount of space in each layer. Now, once I have that and I multiply it by the number of layers, I get the most efficient technology out there. BiCS5, which I'm very proud of, is the most efficient 3D NAND node that is available in the marketplace. The equivalent cell area, the cell that I keep talking about, that charge trap cell, that is powerful enough, that is 10% smaller than anyone else. Because I don't need that area quite as big and I have that shrunk, I don't need 128, 132, 164 layers, I can get in 112 layers. Because I have only 112 layers, I can use older generation equipment. Net of it, that capital intensity compared to a greenfield competitor is 4 times better. That is the efficiency, that is the capital efficiency that Western Digital leads in the marketplace. BiCS5 is the best, most capital efficient node in the marketplace. Now, it's one thing to have a good node, one thing entirely to say how good is that node with respect to reliability and performance. The easiest way to measure the reliability of a technology in flash is to see how many times can I read and write the same bit. Even there, the single level cell, SLC cell, is the purest measure of how good that cell is. In 2D NAND, the best case in our 15 nanometer, we could get 100,000 cycles. That was considered a big accomplishment. 3D NAND in BiCS4, in the 96 layer, baseline we could give you 200,000 cycles. If you put a gun to my head, we can probably push it to get to 500,000 cycles these days. 500,000 cycles on that single level cell in BiCS. That's the reliability that we are talking about. The best reliability you can buy in the marketplace. All right, if it is reliable, how fast can I do it? The next measure of performance that I want to talk to you about is the write performance. Take a single plane. In that die, how fast can I write data? If I know how to write fast on one plane, then I can have multiple planes. I'm comparing our write performance with all the competitors that we could get the data on. You can see consistently 30% better write performance compared to all competition in the marketplace today. That's the power of that single cell when it is integrated with the proper integration. Put them both together, we can now create an array of capacities. I can build a 128 gigabit, 256, 512, and a terabit. Over time, that capacity has been going up. The sweet spot of the technology from the 2D NAND to now has gone up 8x. On the BiCS6 node we just announced, the sweet spot is at a terabit. But you wonder, when that capacity increases, is the performance keeping up with it? We are showing that in that same time frame, performance has increased 16 times. From the under 15 megabyte per second that we did on 2D NAND, we can do 200 megabyte per second on a BiCS6 1 terabit wafer die. Performance is getting better, reliability is getting better, the technology node is efficient. You can see why we maintain leadership in technology. The last thing I want to talk to you about is how do we get these data in and out of the flash? The I/O speed and the I/O power. Input-output speed, input-output power. The modern interfaces are getting faster. PCIe Gen 3, PCIe Gen 4, PCIe Gen 5. UFS, newer revisions, each one of them is getting faster and faster. If the component NAND does not get equally fast or outpace it, then we will become the bottleneck. In that same time period between when we switched from 2D NAND to 3D NAND, where we were at 500 megabits per second transfer rate, now we are talking about 3.2 gigabyte per second transfer rate, and the concurrent reduction in the I/O transfer power. How many joules of energy does it take to transfer a gigabyte? And you do that very fast, you end up with a lower power. So between the two of them, we have dramatically improved both the I/O speed and the transfer energy. So you can see that the reliability and the performance are getting better. That's what leads us to this progression of skyscrapers. 3D NAND scaling has been steadily growing from the 48 layers in 2014 to over 200 layers in the next year or two. That's how fast we've been growing these skyscrapers. So you can see the architecture is changing in each one of them, where we are talking about 2 tiers, circuits under the array, newer lateral shrink methodologies. Each one of them is a big leading innovation that we are taking the industry through as we lead the entire industry. The culmination of all of this is BiCS6. BiCS6 is that node that is been just introduced, that is 162 layers, the minimum amount of layers that are needed to get the bit growth and the performance that we need, gives 2x the performance, write performance of BiCS5, which itself was a very efficient node, reduces the I/O energy by 35%, introduces the circuits under the array concept, so our lateral efficiency gets better. This BiCS6 node is a seminal node as we transform from our BiCS4 to BiCS5 to the next generation BiCS6, which will go in high volume production next year. BiCS6 sets the pace for the industry. You can see how we are transforming the future of flash to being a highly reliable, high performing, high density, low capital efficiency technology node to meet the different workloads. Let me talk about that for a second. The diversity of applications into which flash is growing, the difference in the workloads, the difference in the application requirements. One requires a very high performance, one requires very low power, one requires very low cost, one requires very high density. These are surprisingly different applications that the same media goes into. The vertical integration that we talked about, from the time we create a NAND flash wafer to the time we assemble it, test it, put it into the form factor, load the firmware, and release it to the customer as a well-qualified product, that vertical integration, that customization is what allows us to be able to take that basic technology that we have developed into a customer solution. An enterprise SSD requires very high densities and very high reliability. A client SSD requires very low cost. An embedded NAND that goes into a mobile phone or into a tablet requires very high performance on lower density NAND. A consumer product such as a USB or a external SSD requires a different performance and price point. More interestingly, in the very synergistic fashion, when we use NAND to enhance our HDDs, when that joint product comes through, we have an even different set of requirements. Western Digital has been able to consistently transform technologies into products. So where we have led this flash technology in the marketplace is the following. We imagine a future world where NAND is going to be used. We enable the ecosystem, work with partners to make sure it comes through. We unleash the innovation so that the products are able to meet the customer needs. And we work with the entire storage ecosystem so that that storage marketplace is well served by Western Digital products. That is the power of storage at Western Digital. Thank you. At Western Digital, this transformation of a technology to a set of products that we deliver to the customer's need at the right time through the power of vertical integration is what demonstrates the capability of the company. We think of our products holistically. We think of our products in reference to where our customers and our industry wants to go. We also look at it in light of what we do to our society, where storage is enabling a transformation in people's lives. With that, it is my honor to introduce you to a remarkable entrepreneur. I would like to play a conversation that I had with Luval Mayen, who has been a pioneer in using gaming to transform people's lives.
Luval, it's wonderful to be talking with you again. Welcome to this conversation. We've been working together with your foundation for a bit of time now. Would you please tell us, what does the foundation do? How are you working with it? What's unique about what you're doing with gaming and the foundation?
Thank you so much. It's really an honor for me and a good opportunity that I've never dreamt of to be able to have this conversation with you today. It's been an amazing time. I know everybody is in the pandemic. I know everybody is having a lot of difficulties, but there's one thing that I learned, recently, and that is, we use our past and our experiences to be able to create a sustainable future for the people. And for me to have this opportunity with Western Digitals and everybody and all the product that they are building. The work of my foundation is, for me, as somebody that grew up in a refugee camp, and being where I am today, I realized that, the only thing that we need in life is to be given the opportunity to be who we are, and I realized that, it's really very important that everybody in the world, has talent, but the opportunity is not, is not well distributed to everybody. And to me, I feel like refugees are people that deserve quality education. That's why I started my foundation, to be able to give educational, tools, so that refugees in a refugee camp can be able to learn. Education is actually what made me who I am today, to be able to follow the right path in life. And that right path in life is actually the opportunity to do what you love, and that is gaming. And who is that person? Was my mother, who worked 3 years every day to be able to save $300 to be able to give me my first technology, which is my computer. So I think, to me, the only way to do that is actually to invest in refugees, invest in people that do not have opportunities. Some of them right now, actually, it's an amazing thing. A refugee that attended my courses for the last 3 months won the European Artist of the Year. He is actually a designer. And when you look at that, he never had these opportunities, but I gave them the opportunity to learn, the opportunity to design things that they love. And that gave me so much hope that I'm not the only person that grew up in a refugee camp that can become who I am today. And that's why it's really amazing for me to partner with Western Digitals.
So Luval, I want to pick up on that thought. Mm-hmm. Technology we think of as products and new developments. But in your case, technology actually transformed a life. And I want to make sure, I want to hear from you, how do you personalize the technology? What does technology mean to you? And as a secondary question, how did you come across SanDisk, and how did you use the SanDisk product?
Technology is who we are. We get ideas that inspired us to be able to create technology. And those ideas are things that affected our communities, the things that we need in our society. And those things inspired us to be able to create that sustainable time for the time that we are living in. When you look at me, the first time I saw a computer was like 2017. And I mean, when I like, that was like 2007 when I was in a refugee camp. And when I saw the computer for the first time, I live in a refugee camp. You know, my intention was like, wow, what is that? I've never saw a laptop before. I've never seen anything. Like 2007 was the first time during a refugee registration, because there were no like, you know, computers at all. And I told my mom, I was like, what is that? And she was like, that's a computer. I was actually like, how did you even know that's a computer? Because she has never been to school. She has never been to school. So, but by that time, I felt it. I became part of it. You know, and I felt like I want to use that one day. And the reason is because, you know, by using technology, I can be able to like create something that I believe in. I can be able to create an environment where people can be able to live the rest of their life. And that's actually why I decided to make games. And the reason is because there's things that give us the resources, that give us the opportunity to create things that we love. You know, before I start creating games, I have to think about, okay, what do I do to learn video game, to be able to create video game? You know, I need to like know programming. But living in a refugee camp was like, there was no internet. There was no school. There's nothing in a refugee camp that can help me learn the technology that I love. And that is, I have to like do a lot of work to be able to get that. And that's when I started, like the first time I have access to SanDisk. So what I would do, I would go to an internet cafe, download all the files and put them in a SanDisk and use it to learn. And I would work every day, 3 hours per day, to go and be able to charge my computer. And without that SanDisk, without those products, I wouldn't even have access to learn computer. And I think that's why, like, I feel like, you know, I'm part of it right now. I'm part of, like, you know, there are millions of people, there are millions of refugees. And that's one of the things that I didn't talk about before, that, you know, people lose their memories, and they lose their memories. The memories might be pictures, might be videos, might be like, today, a lot of people ask me, hey, Lual, do you have a picture of you when you were in a refugee camp when you were like 5 years old? I didn't have it. I didn't have the place to store it. And I would love to do that. People come to me and say, we want to make documentaries about you. I'm like, I don't have the videos. Like, you know what I'm saying? So it become personal to me now. And I feel like this is the right time for us to have like tools, you know, products like, you know, SanDisk. And that's one of the things that I'm doing in my foundation, to be able to like help kids in refugee camp, families in refugee camp, store their memories and actually accumulate them, because those people might one day need them.
Thank you, Lual. It is an honor for us at Western Digital and me personally to be helping you along in this foundation, be part of your life, and making sure our products and solutions are actually going to be in a cause such as that you are doing with the foundation. Good luck to you. I want to make sure we are there with you every step of the way as you go help the refugees around the world. Good luck, Lual. Thank you.
Thank you so much. Thank you. Yep. Mm-hmm.